what you're going to tell us about.
Okay, yeah. My background has been as a system director at Arlo Technologies. I don't know if you guys have heard of a company called as Arlo. So basically what they do is they do camera and backend services for home security systems. Basically, if somebody is walking in front of the door, it takes a picture or video and sends it to the cloud. And then the user gets a notification on their mobile app to say, here is a person, here's a vehicle, here's a dog, here's, things like that, right? So my job was to do an end-to-end validation of validating all the PM use cases, saying, hey, the camera has to respond within a certain number of seconds. It should be available to take this many videos. It should be able to have a low latency and all of those things. And also the accuracy, like what Ajay was saying, right? If there's a person, it has to be a person. If there's a vehicle, it has to be a vehicle, right? It cannot be false alarms, because in the home security industry, it's absolutely critical that, we do this correctly, right? So what I'm going to share my screen. Okay. So I know I have a very less amount of time, but I want to take this discussion. Maybe this is the first level of discussion, but it will be useful at various angles. I hope you can see my screen. Can you?
Yes.
Wonderful. So I think from the discussion today, I can slice this and dice it into two angles. So at a very high level, what is systems engineering? And to tie into the discussion that we had right now about vision and things like that, I can go much deeper in those areas also. So the very interesting thing is, I'm just going to take a minute to share the goals of what system engineering is all about. So in real world, a PM comes back and says, here's a new product that we are coming up with. Here is all the things it has to do. I want to make sure that, the revenue growth can happen because of this new product. Now, how do they come up with these metrics? Maybe they compare it with other industry things, or maybe they have a gut feeling that, this is what it has to do, right? Now they come into the engineering team, they have a initial board of designs and things like that, and they come back to us and say, hey, make sure it works that way, because before they put it into a nice case and things like that, we just need to make sure it's, it's the right chipset, right software that goes in, right firmware. It's a very hard problem. Vision is, it's a very, very interesting, but a challenging problem, but I'll tell you why. So basically, today I'm going to be addressing, two scenarios. One is, why is it hard from the system perspective? And second thing is more targeting towards the vision side of things. Okay. So in this picture, right, you want to be able to identify, a package theft as quickly as possible, right? Because if somebody, it's just only a matter of seconds, just comes in and takes out the picture, right? But does anybody know what happens, if a video captures this thing, can anybody tell me what could go wrong in this picture? Anybody?
The image might learn, it might associate the person with the door. So if you remove the door, it might not recognize the person.
It might recognize the person. What else could go wrong?
In recognizing the image?
All you can see is, you can see a camera in the front of the door, right?
Yeah.
And as a user, I'm expecting that the camera is doing 100% correct. That's a good assumption to have, but in reality, that's not how it works. Now, we want to show, where are all the pitfalls that happens, when the picture is being taken. And then finally, a notification comes into the user to say, yes, this is a person. Yes, this is a package, right? So there are so many gotchas where, when this particular pass. So the first thing is, a camera takes a video, right? And this is as complex system as you can, because there are so many chipsets. There is also a sensor which detects whether, a motion is happening. And, that waking up of the system has to happen at the right time when a person is coming in front of the door. The second thing is, the person has to come in the point of view. This is called as a field of the view, right? If the person is here, or if the person is here, you're not going to have a chance of that person being recognized, which means if you're seeing misses in your video captures, this is likely the reason. Okay, so which means it has to be, put at an angle which is more likely that it's going to capture the person for some time. The next thing is, all of these cameras are wire free. And so what happens here is, depending on your home network, your home network can be as busy as possible. You might have a microwave running, which can also interfere with your Wi-Fi communications. You can have your, computers, people are watching Netflixes and things like that. That could also interfere with this is what we call as a base station. Okay. Now, the way it works is it takes a picture, it takes a video, sends it to the base station. The base station encrypts the video, sends it to the cloud. The cloud does the processing of the video and sends it to the AI ML, which is what Ajay was talking to, where the model building and feature things and everything goes here actually, right? The AI ML model inferences that yes, it's a person, yes, it's an animal, and things like that, and sends it to the backend, and the backend has to send a notification to the mobile device. Now, there are a lot of points of failures where, a PM, when they come in and say, this is what it has to perform, which means in a system, everything has to perform at that point of time, right? Meaning, SMS notification has to reach you within the 3 seconds, which means, all of that has to take that into account. As a person is walking in, all of that has to be burnt in to say, what is the time it is taking for each of these systems to be able to serve that particular request. Now, one more interesting thing. So this is where the system engineering challenges. So we did a lot of innovative work to collect data at all of these points. We actually, I'm just going to take one more minute. So we actually rewired these cameras. We simulated n number of simulations to take a video with the different light settings, with the different resolutions, with the, all kinds of things that you can imagine here to strengthen the software that is on the camera. Now, the Wi-Fi, the box says, it's going to take about, 20 feet or 30 feet, but in reality, it may only be 10 feet. What they're putting in the box is in a very clear, no interference kind of a setting, right? But the PM doesn't know, because they always want to be the market person to say, yeah, it has to perform, it will be performing, but we have to make sure that it is performing at that optimal level. Now, the backend can be, right? There's a lot of cloud services running at the same time, at any point of time, if there is a network hiccups here, the internet, Comcast is not sending the packets here, you're not going to be able to reach all of these things. So we can simulate a lot of bandwidth scenarios here, meaning, a person has a low bandwidth, medium bandwidth, high bandwidth. Basically, what we need to do is we need to come up with customer usage patterns. What is the customer going to be doing in certain scenarios? And that is the conditions that we need to validate, right? That is what a PM is expecting. A PM is not expecting that everybody is going to have tens of cameras, but maybe 2 cameras, 1 doorbell, 1 baby monitor, for instance. And that has to perform. If that doesn't perform, the next thing is churn. People are just going to say it's not working. Right? I mean, this is actual business use case that we are validating. Now, Coming to the AI ML model, which is what Ajay, and just an extension of what Ajay has been doing, right? So obviously there is tons of data that tons of videos that people have submitted to improve these models, and understand that your model's accuracy is as good as what it's trained for, right? Which means you need to have enough training set, enough tuning of these things. If it varies from that, the accuracy is going to be low for it, and that is given, right? So what it is in real world, what we did here is we had about 60,000 or 70,000 videos sitting there. Now, what I did is I operationalized the way we monitor the accuracy and precision of each model building, because okay, so just one 30-second background. So like what Ajay did, there is a company offshore where these videos are given, and the videos are tagged by labeled by somebody out there, right? Okay, let's say if they were given this particular video or picture, they may say person, right? I mean, obviously there's a person here standing, right? But maybe what it is this person has got a package in his hand. I don't know if you can see this sort of, right? This person has got a package in his hand, right? Now, at the same time, some people might label this as vehicles that are in the background, right? Now, what I'm saying here is, if this picture is not labeled with a vehicle, for instance, and if this picture is fed to the system, it's going to come back and say this is person, right? It's not going to say, oh, I found a package. It's going to have a very low confidence that it's going to be a package, right? So model building is very important. Training the model is very, very, very important. Now, in real world, what I did is I had taken a random sample of the videos. The reason I focus on random sample is, I did not focus on, high resolution cameras or low light settings. I just want to pick up a random sample of data set. And then what I did is I validated the labels using a Microsoft Vision API. So I took about, let's say 100 videos. And each week I put into a pipeline where I fed each of these videos into the Microsoft Vision API and compared the labels with the precision and recall of what this whole system is trying to say, right? So what I would do is I would feed the same video to this system, which will go to the backend, which will come back, which will do this, go to the AI ML and say, it found a vehicle. Maybe next week they fine tune this thing. It'll go back. I do this, for hundreds of videos and says, oh, I found a person. And then maybe I found a package, right? Number one, what I did is I did the labeling validation. And number two, I productionized it. Now, in terms of calculating the precision and recall, because in reality, the models are getting constantly refreshed. Every single week, people are doing feature tuning, improvements to the model. It's constantly moving. All of these pieces are moving, right? What happens here is if the video that I'm feeding is not captured fully, then also the model inference is going to fail, right? I just want you to understand the modes of failure that happens and the changes that are happening in each of these systems individually, and how we put together a system to make it into a science of productionizing the validations of the labels and improving the accuracy of when a camera is saying this is a person, there is 99% confidence, 95% confidence that it is in fact a person. And also how we optimized, what are the ways that we optimized to make sure that this camera chipset, the firmware, is performing in coexistence with all of these systems working together. It is not You're not just seeing the mobile app here. It is everything together is what you're seeing when the person sees you. Right?
This is amazing. This is amazing. Okay, I just want to do a time check. I said we'll finish by 15. We are going past. Should we wrap up, and or people have questions for Suresh? He's going to be back. We can do a separate system engineering and AI talk if that's of interest to you guys. And Suresh is also going to be part of some live labs, so maybe some of you will get to interact with him. So questions, anybody has questions?
Yeah.
Great session. Okay, thank you, Mamta. Should we wrap up? Do you have any questions for Suresh, guys?
I think Yashwani had a question.
Yash has had her hand up for a long time. I don't know if that's from the past question or new question. Do you want to stop sharing your screen, Suresh?
Okay.
So my question is, when you talked about system engineering,
Right.
starting from the camera till the AI models, that entire thing you define as a system, and you experiment with it and get it to productionization, or a part of it you do it?
It's the whole thing. It's the whole thing. So I was responsible for end-to-end system.
Okay.
So there are multiple systems running. The firmware system is running. The cloud systems are running. The AI models are running. Right. It's the whole thing is system.
Okay.
Yeah.
And I have one more question. I'll just go quickly. So I have heard these terms such as edge AI, AIoT, IIoT. So when you showed that it's an interconnection of devices, so can you pinpoint and say what is edge AI, what is AIoT or IIoT in terms of
Okay. So I think edge AI is becoming more and more popular and prevalent right now. So the camera itself, right now what it's doing is it takes a video and then it sends it to the cloud for inferences. Now, when you do an edge AI, the chip that is on the camera, it's going to be a new small chip that's on the camera, which will make some inferences about, 4 categories, for instance, like, person, animal, package, and things like that. That happens on the camera itself. It doesn't have to send because, when it does all this traffic, there's a lot of lag and, things can drop. And also privacy, right? So basically, the new model of cameras that are coming out will have an edge computing chip that is sitting on the camera itself. But only the metadata would be sent to the cloud, meaning, on such and such time, the camera found a person, or, it may not say, let's say an animal, right? It can be a dog, a cat, or, anything, right? It might say, it found an animal. So just the metadata would be sent to the cloud, but not the actual video shipping, unless it is requested by the person. So but until now, everything has been happening on the backend cloud.
So in your case, Suresh, it was all sent. The video was sent, and the actual data was sent and done.
That's right. That's right.
So with Edge ML, the model will run on the device itself.
On the device itself.
And when you, just one clarification, when you said with Edge ML, not in your case, but in Edge ML, when the model runs on the edge and only the metadata is sent and not the data.
That's right.
That's more like transfer learning, right? So the model data is sent, not the data. The learning of the model is sent.
That is true.
Yeah,
that is true. So the challenge here is the battery life. Now, if you're going to run a whole big computing on the camera, it's going to consume a lot of battery. So the challenge at that level is how much milliwatts does that edge computing chip consume? Because at that level, we measure all of these things at the camera. How long does the battery life stay? They say it's 60 days depending on the usage. But if you're going to put a special chip, how much milliwatts or watts it's going to consume? So all of that is in consideration for the edge computing. Did I answer your question? Yeah.
Did you hear my earlier question about modeling?
Yeah.
Which model were you going to use when you selected the label, right, Henry?
So in my case, I was treating this effort as a black box because I was depending on Microsoft Vision API to give me a certain set of labels. And then the black box of, what Arlo was giving us. And then what I did is I did a match of, the labels. So one thing, I don't know if Ajay is there also, right? But, there is called as entity rollups. A person might say a blue shirt man, for instance, but another person might say a man or a human being, or I'm just giving you the labels here, right? I mean, people can tag this anyway, but one thing to understand is whether it all rolls up to be a person or a vehicle or an animal and things like that, right? So there's a lot of things at the labeling level itself. People can label this in any way possible, but it needs to be rolled up so that a final decision can be made when you send the message to a user on a mobile phone.
We did this in class where I showed a picture and people, I've shown this here also. You have a orange being picked by a hand, so you see the orange and the hand and the sky in the background, and so the labeling can be done in so many ways, like the example you were saying. So whether it is a fruit, whether it is a ripe fruit, so the students have a lot of things. So that's the entity roll up. So it's not that, so you have the training data, but it's kind of not lost somewhere because it was labeled differently. So it's all interconnected and rolled up together.
That is true.
Okay. This is very good. And there's a last question I want to take and want to wrap up, because I think we can stay on and do a live stream for a long time. So maybe we will bring you back. And Suresh, you're going to work with me on the MDS data, right? Because you're also learning data analytics. So this is what I found fascinating with Suresh is he's learning data analytics and says, I want to work with AI, but then he brings this system engineering experience and already was working with AI in a very different dimension, which I did not know. So that's why I wanted him to talk to the class. So you kind of see, okay, PM creates the requirements and say, okay, then who creates the business use case? And now Suresh just said, PM is my internal customer, creates the use case, and we just keep, and I go and make sure I do the validation. And he's talking of even automating the validation. So I found that this whole AI in system engineering is a whole new field by itself. But then Suresh wants to move and do more on the data side. So hopefully, we can follow up offline. Anybody who wants to work with me on, any of the, if anybody wants to start one more project with the labeling, I'm happy to, help you guys frame that and go do that. Or if anybody wants to help me make sense of the MDS data as I'm working with KiwiBot to start the live lab will be a course in September. But if anybody is interested in that, I'm happy to follow up, and I'll email the ones who are missing and seeing this later. I will email you guys. Okay, one last question from Pamela, and then we should close for today. How are you providing feedback to the machine learning model?
For me?
Yeah. Yes, question for you. How are you providing feedback to ML?
Okay. So the precision and recall, the pipeline that we created, feeds back to the team where they can improve on, why a particular video. So it all goes back to the guidelines, because I worked at Yahoo before. Basically, there's a set of guidelines that the editors need to follow when they are, labeling certain things. Now, it's a very, you have to give them a very clear guidelines to say, if you see certain of these things, this is what you need to tag us. Now, what that involves is maybe people are not being trained properly. People are not, following the guidelines. So it is improving the guidelines of, what people can label a certain set of videos and pictures, right? So the findings that we did in this exercise fed back to the team where it was further to improve on the labeling and precision and recall of the models, basically. Because this was happening more periodically than each week. you know, they were getting the feedback more constantly than before.
Okay.
Okay.
Okay. With that, we should wrap up, guys. This has been amazing. Thank you, everybody. And I know we went longer. And, you know, I hope you see the connection of what I'm trying to say when I say, you know, go deeper and think about it from a business angle, not just, you know, think of training data is, yes, we have to get training data. Somehow we need a person or a role like Suresh who's going to validate that. And this even other roles to even get more synthetic data for training data to kind of multiply what you've got. So there's like so many dimensions to this. There's so many roles in there. So I'm hoping you'll all land in those and come and tell us your happy stories of what you're working on. So with that, I want to wrap up for today. Thank you, everybody. And this recording will be online by Friday. I mean, and I do my YouTube and LinkedIn live at 6 p.m. on Friday. By the time this should be live, and I'll be sharing there. Otherwise, if you're already on Weekly Wednesday on Business School of AI, you should be able to access that. And if any of you are thinking of working with AI, or you are thinking of your job roles or changes, just talk to me. I always enjoy having this conversation, and I'm hopeful that I'll be able to help in some way. Okay. With that, let me wrap up. And then if you're, I'm counting on you students to tell me if, you know, if any of the classes that I'm offering for September, if that's of interest to you, the no code AI, there is going to be a responsible AI course from Renee Cummings. And then we have this data, the machine learning model AI, the data analysis stuff that Julian Carbonell is going to teach. So I'm offering multiple small master classes, or you can just do one of the 3 live labs, or just take the no code AI class. So that's kind of the model I'm going for. So sign up to get the fall catalog if you're exploring any of these courses, or just talk to me. And let me give my email. It's sujampe@businessschoolofai.com. Okay. And with that, I'm going to wrap up. Stay safe, and I will see you guys next week, or some of you on Friday if you're joining. Thanks, Cam. Thank you for all your comments. Thank you, everybody.
Thank you. Bye-bye.
Bye.